Now that the particles are moving fairly decently, we want to get them to spin. One of the intriguing effects of any kind of heated explosion is the rotational vortices of gases expanding outwards from the explosion point. And at the moment we don't have any rotation whatsoever. We simply have particles maintaining their orientation yet moving outwards. To control this, we're going to use a spin particles compound, and I'm going to add it after I've added my forces. If I have a look under the orientation category of particle compounds, I'll find the spin particle, bring it into the graph, and execute it somewhere after my add forces. So I'll execute after my set particle color and jump in like so. Now, at the moment, all of the particles are going to spin at exactly the same rate, and they're going to tumble, which might look okay initially. But I want the particles to actually start rotating quickly on their initial explosion and then slow down as they get further and further away. Or, depending on how I want to art direct it, reverse that. So this is where the initial values that we set early on, the offset position, come into play. Now that we have a position where our particles were born on the surface emitter, we can compare that to their point position as they move through their explosion. So we can subtract those two values and use that as a position to calculate spin. So back on the spin compound, rather than using a random tumble at a spin rate that we define here, I'm going to use the particle input position that I provide. I'm going to build a little ice tree to control that. So I'll pull the spin particle out over here so I can give it a little bit of space. And I'm going to get the particle position, so I'm going to use a get data node. And I'm going to look for the point cloud's point position. And I could actually just replace point cloud with self in case I wanted to use this effect elsewhere. And if I copy paste that, I actually want to go in and get this offset position. So under get self point position, I'll look for the offset position. And I'll subtract those two to generate a value that I can use to drive the input position. Of course, I could always amplify the effect using a multiply by scalar. And to drive the spin rate, I'm going to get the particle's age. So as the particle is born, so let's get ourselves an age compound. Let's run that through a function curve. And then multiply that by a scalar value, should we need to control the amplified curve, or the amplified spin rate. So right now we'll leave the factor at 100%. So I'm going to take the age function curve, and I'm going to have it so that the particles are spinning a little faster at birth, and then they're going to actually slow down. I'll double click on the multiply by scalar, and we'll see how that looks. So in this case, they're actually speeding up. So I actually want to reverse this graph, so I'll move the graph like so, and move this keyframe down to a value of 0. If I'm not sure, I can always access the key properties and make sure that it is at a value of 0. I'll fix this function curve. There we go. And again, I'll access that multiply by scalar and try and tweak the effect a little bit. So it actually just stopped dead, so that's not very cool. So I'll just do a little bit of tweaking. And we're going to always want the particles to continue spinning at some rate, so that's why they're stopping dead at a point. So let's actually give them a little bit of value here, so they can spin quite slowly. Again, it's just trying to get that value working properly. Let's bring these up a little bit more. There we go. That's not looking too bad. I'll take the intensity down on the vertical axis, and we'll just control that keyframe a little bit. There we go. And I could always ramp down the effect by using the factor, the scale factor. Okay, that's not looking too bad now. Looking a whole lot better. The colors aren't the most appealing. Okay, I think I can go with that. So I'll just do a quick comment in my ice tree that pull in a group comment here. So use an inverted age, or it's not really using an inverted age, it's actually use age and start spin at a higher rate and taper off over the particle life. Alright. So I'll pause there and we'll continue on with some more randomization of our